Hi, this is going to be quite an interesting talk because I am a short notice replacement and I haven't practiced this talk in a long while, so we shall see how much I remember. Fortunately, when I finish, we're going to the pub. So 10 minutes I think will be fine. Also, I'm using this microphone thing. I'm not very good at mics in general. I'm not good at handheld mics and I tend to gesticulate. So half my talk is going to disappear because I can't move my right hand. So this is going to be really interesting. I want to talk to you about APIs. I integrate with APIs a lot and I write APIs a lot. This talk is mainly about my experiences of integrating APIs and how much hatred I have for badly written ones. So this is my opportunity, standing up here, to tell you some of the things that, admittedly, are probably quite basic, that you should never, ever get wrong in your API, if you want me to use it. First thing I want to think about is, regardless of what I'm going to tell you, your API needs to be fit for purpose. It needs to do what it's supposed to do. We write APIs for a reason. The key reason is to ensure that we are furthering a business goal of some form or another. I'm self-employed, I work for other people, so I am furthering my client's business goals. Maybe you work for a company, you are fulfilling whatever that company's business goals are. That is why we write the API in the first place. There's no point in having an absolutely fantastic API that doesn't do what it needs to do. So that's the first thing you need to make sure you get right. And then I want to talk about these things about an API. What makes a good API? And I've broken it down into these rather arbitrary 5 things that I think are important. So we're going to cover malleability, we're going to cover how correct they are, we're going to look at error handling. Documentation is a thing, and allegedly, but not for FFI obviously. And I can't actually say anything about APIs without at least mentioning security at some level or another. So malleability. Good API is malleable. What do I mean by malleable? I mean it's flexible. It can be changed. And the first way to make that happen is you need to decouple your representation, which is the technical term for the payload, the bit that goes down the wire, from your internal business logic and your business storage and your models. When you write HTML websites, you have what we call a view layer. You all do have a view layer. You probably use a template language, something like Twig or Blade or whatever. Your API works the same way. It has a view layer. The advantage of having a view layer is that you can separate the choice of what you are sending to your client from everything else. Don't miss that step out. It is really, really easy to take the output of your database, JSON encode it, and send it straight to your client. Do not do this. It's really simple, it's really quick. It will come back to haunt you because you cannot change things. Your database is now tightly coupled to your output layer. You would never do that in an HTML website. Do not do it in an API. It's just horrible. We can also make things better than that. We can use links. We use links on the web. We can use links in our API. And we call this hypermedia because complicated words sound cleverer when we talk to clients. There's probably other reasons, but we call these hypermedia. It makes APIs more explorable. Again, this is all about decoupling and making our APIs more flexible, more malleable. Key things I like about it is being able to rename my endpoints. In particular, moving things to CDNs. I do fairly small stuff, low scale. High value, not very much traffic. And then we might get a bit more traffic and we think, oh, we'll put some stuff on the CDN. And if we have not hard-coded everything at our client level, we can actually do stuff about this. We can do things about this. And this is what it looks like. This is a JSON payload, because JSON is the lingua franca of APIs at the moment. Don't assume it will be forever. I know JSON is common now, but when I started, nobody had heard of JSON. And with any luck, nobody will have remembered JSON by the time I finish. But we are where we are at the moment. So here we've got some sort of payload. There's a little bit of data down the bottom, currencies and status and stuff like that. And then we've got a section called links, which are things related to this representation. So this represents maybe an order that has been shipped, and I might want to get to the customer. So my information about my customer is obviously in my documentation, so my clients could all just hard code that information. Give them a customer ID, they can hard code everything else. Try not to do that. Give them the full URL to go and get that customer record, because then you can change it if you ever need to. If you decide, in this example here, our customer is number 32, at some point you discover that your database needs to be sharded, or your database needs to become distributed, or you do something weird like turn it into NoSQL, and suddenly you want to use UUIDs. Life is much, much easier if you are giving your customer all the information, your client, sorry, all the information as a direct URL that they can just call. Make life a little bit more easy for yourself. This is where all the basic stuff is. A good API is correct. You will get things right. HTTP verbs are a thing. They matter. People far cleverer than us created the spec for HTTP. We know they were clever because it's lasted 20-something years. And a version 1.1 lasted over 18 years. That's a long time. They got that spec right. And it's been remarkably flexible as a spec. So HTTP has got these verbs. They mean something. We've got get, put, delete, patch, post, and a few others, but these are the ones that matter for APIs. Key thing you need to consider here is whether it is idempotent or not. Idempotent is another one of those complicated words to make us sound clever. It basically means if I call the same request again, will there be a side effect on the server a second time? So what do I mean by that? Let's take a GET request. If I go and do a GET query, and I call a GET query a second time, and the third time, what's going to happen? Nothing. I'm going to get the same data every time. That's idempotent. It does not change on the server. If I do a delete call to the server, you can imagine a delete method is going to delete some data on the server. So we're going to take our request, we're going to call delete on our order, we're going to delete that order the first time. What if I call delete a second time? What's going to happen? Nothing. Because the order has already been deleted. There is no other side effects. I can call delete 100 times and there will be no other side effects on the server. That is idempotent. What about post? Post is traditionally used for creating a new record within a collection. So you would post to orders to create a new order, for instance. Or if you're Twitter, you post to the tweets collection to create a new tweet. Something like that. If I post a tweet collection, I create a new tweet. If I call it again, I'll create another new tweet. That's not idempotent. That's really important if you happen to live in Worcester, need to go to London down the Cotswold line, where the signal on the mobile phone is terrible. It's really, really common to get timeouts. It's really, really common that I can send a request and I do not get a response. What do you think happens if the client doesn't get a response to a request? It's going to send the request again. And we get double posts, we get double orders, because it's not idempotent. If you can make your API idempotent, you simplify an awful lot of problems related to poor connectivity. There are other benefits as well, but that is one that most people notice quite easily. That's verbs. Status codes also matter. You've all seen status codes. You're very well aware of 500 internal server error. We've all seen that one a lot. 200 OK, 404 not found. They are grouped. They are 3 digits. The first digit is the group digit. 1 is informational, 2 is a success code. If you get a 2 something back, everything worked as expected. 3 something means that there's going to be a redirect. There will be a location header to go and look at. 4 and 5 are errors. 4 means that the client can probably fix it, and 5 means the client probably can't fix it. Do not ever send an error message with a 200 OK. Because the internet doesn't work that way. And the reason the internet doesn't work that way is that when we see a pretty diagram on the internet, there are lots of interconnected nodes. And some of those nodes are proxies. Some of those nodes are caches. They are of no interest to us as a developer, but they matter to the working of the internet. They are an intrinsic part of the internet because the internet was designed to withstand a nuclear attack. It was designed to reroute, it was designed to cache, it was designed to have proxies in it. Proxies and caches follow the status code. Who would have thunk it? So if you send a 200 back to a client, every proxy and cache on the route will cache it because it was a successful message, assuming you're using cache headers. So you can then go and fix the problem, and the error is still in the cache because you sent it as a 200. If you'd sent it as a 4 something or as a 5 something, none of the caches would have cached it. They would have all ignored it no matter what your cache headers were, because they know it will get fixed and you don't cache errors. This is why we use the right status codes. It matters to the way the internet works. There is not a single connection from your client directly to your server in most cases. And some ISPs, British Telecom for instance, are particularly aggressive at doing this and screwing up everyone else. Media types, another part of the HTTP spec. The content type header enables you as the server to understand what data has been sent to you. So the client will send you some data and set the content type to tell you how to decode it. The client can also send you an accept header to tell you what format of data they can read. If you can, make sure you honor that accept header. Today, all you're going to do is accept and send JSON, because that's the only format that matters today. Unless you work in enterprise. I'm working in enterprise a lot. I would love to use JSON sometimes. We're still in XML world. We're in lots of XML world. Some of XML world is quite nice. Other bits of XML world are not quite so nice. But we need to send XML, we need to send JSON. The accept header is the way we can tell the difference, whether our client can read XML or whether our client can read JSON. Now I know what you're thinking, you're all working for a startup, you're doing all the cool stuff, so you're only working on JSON. Go back to what I said earlier. At some point in the future, new formats will turn up. You might have to use that weird Google protobuf thing, or whatever. New stuff will turn up. If you've already got support for accept, adding a new format is easy. Just makes your life a little bit easier. I've talked about versioning of APIs because people expect me to have opinions about it. I don't have an opinion, particularly, other than don't kid yourself that you can version your API. Nobody can version an API. If you absolutely cannot make your changes in a backwards compatible way, then create a new API. You can call it version 2 if you like, because then it makes the marketing people happy. But treat it as a brand new API. Every single case that I've seen, someone tries to support a V1 and a V2 within the same code base, They have broken V1 within 2 years and made it unusable. So you may as well not have it there. Be honest with yourself. You're either going to break VC all the time, or you're going to create a separate code base, a separate API, and call that V2. You shouldn't need to version often. You're doing it wrong, and you are not thinking properly if you are finding yourself having to change versions in a backwards incompatible way regularly. Most things you can do in a forward compatible way. We can introduce new fields quite easily. That's a great way of doing it. We can add new endpoints. We can do new verbs. We can change quite a lot of things without breaking backwards compatibility. Think very carefully about whether you ever want to break backwards compatibility. If you can avoid it, because you've just doubled your workload. And you don't double your pay when that happens. Well, I don't know if you do. If you do, I want your job. So, new version is a new API. Separate the code base. The actual mechanism of how you name it, I don't care. V2 is fine. API 2 on the domain name, that's fine. Use a server header. I don't particularly care. I care that you document it, so I can work out what you've done. But the actual mechanism doesn't particularly worry me. I'm not particularly a zealot on this. Just be aware of the consequences of deciding to version your API, because it will have consequences. So they're the key things I want you to think about in terms of correctness. They're all fairly fundamentals. So many of the APIs that I deal with get them wrong. You can forget all that though. I'll be disappointed, but you can forget all that. This bit, pay attention to. This bit is the bit I absolutely 100% care about. Error handling is the most important thing you can ever do for a good API. Make it a first-class citizen of your API. Make it arguably even more important than the actual production working data that you're sending through your API. Get your errors right, because it matters to the people you care most about, or more accurately, your business cares most about. The people who are integrating against your API are developers, like you. Developers are very lazy people. You've probably noticed this. Make your developers' lives as easy as you possibly can, and they will use your API. Every single one of your developers who first onboards with your API will not read the documentation. None of them. Absolutely none of them will read your documentation. What they will do is they will get Postman, or they will get curl, or something like that, and they will hit your API endpoint and see what happens. And what happens at that point? They'll get an error message. So pretty much all of your potential customers, the first thing they're going to see when they play with your API are lots and lots of error messages, because they have got no clue what they're doing because they've not read the docs. If you can make those errors understandable, clear, and ideally fixable by them without having to go to the docs, then they will stay with your API and they will recommend it. They will say, this is a great API, because they got further in it. They were able to get it working. They got an error, they read the error, they fixed it, they went to the next stage. Errors matter way more than you would think, because of the audience of your API is essentially your customers. So what do I mean by first-class citizens? Firstly, you're going to put some error codes in your payloads, error payloads, some sort of unique string, because we need that unique string to search on Stack Overflow. Otherwise, nobody's going to be able to work out how to fix it. Nobody else looks at anything other than Stack Overflow nowadays. Those codes are useless for understanding what's gone wrong. So also write down in fairly good English, or whatever language you're actually supporting, a description of the error to help the developer understand what's gone wrong. So they can read it straight in their curl response and fix it. That would be nice. I would kill for that in some of the APIs I deal with. Pretty print the JSON if it's an error, because the people reading the errors are the humans. It's so much easier to read a nicely formatted JSON output. And I know that something like Postman will do its best to format it for you nicely, but sooner or later someone's going to end up on the command line. Make their life easier. Use a standard for your formatted error messages. And the standard you should use is RFC 7801, which is a really, really easy to read standard. The RFCs are mostly fairly easy to read. RFC 7801 particularly is. It's a description of how to do an error payload. And if you use this format, then people can use client libraries to actually parse it and use it, which is quite nice. It includes the status code. I know the status code is here in the right place, but it also puts it in the body because it turns out that there are some certain, look at it, Microsoft client libraries out there that hide this information. Type, title. Title is in English, so we can understand what's going on. Could not authorize user due to an internal problem. It's a 503. Some detail, further information to help the user. This authentication service is down for maintenance. Right, now the user knows exactly there's no point in carrying on and it's time to go get a cup of tea. Instance is a URL. The idea of the instance code is to provide a place for further details about this specific problem, so that the developer, our client user, can immediately go to the correct help page. How amazing is that? Can you imagine how much easier integrating with an API would be, like, say, PayPal's, if it told you where to go to find the right docs? And there's that error code. That's the one that the computers can read. I quite like alphabetic ones, but some people just use straight numbers. Doesn't matter, just make it consistent. Never ever change the computer one. If there's a spelling error in it and it's in production, leave the spelling error there. That's how we got referrer, by the way. Right, so that one of those links goes to the documentation. So let's write some. Please, write some. And then link to it. So we know how to link to it from an error message. This is how you link to it from within your actual API payload itself. You can use the link header. There's a header documented in the HTTP spec. This is where my docs are. We call it the profile. If you set the rel to profile, it means this is the documentation for this thing. That's really helpful. There's no ambiguity. So I deal with quite a lot of e-commerce type websites and things like that, and I integrate with quite a lot of payment gateways. I don't know if you've worked with lots of payment gateways, but they're built by banks and financial people from a few decades ago, on average. And they bring out these new products. But because their marketing departments suck, all the products have got basically the same name with a slight change of wording. So it's really hard to tell which particular product your client has bought, and then which particular set of docs refers to that particular product. That's where the docs are, for the payload that I've just received. How easy would it be to actually find the stuff we need to find? If you want to put it in the body, just put it in your links. You've already got a links section. 2 types of documentation are required. You need tutorials and you need reference. Everyone thinks they only need the reference. And the reason we all think you only need the reference is that we can get the computer to generate it so we don't have to write it. And we don't like writing docs, do we? So reference documentation is important. Correct reference documentation is important. Incorrect reference documentation is the worst thing ever. But I do need to know exactly which fields I need to send to your API, and I need to know exactly what the meaning of every property you send back to me is. I need to know the range of all the values that I'm going to send to you so that I don't screw it up. That's all reference documentation. You can automate nearly all of that. The way I would automate it nowadays is OpenAPI specification. This is a format that is gaining momentum. It's fairly comprehensive, it's got a few gnarly bits in quite a lot of places, but it's the way forward. You must document your API so that you can turn it into reference documentation. So use a standard, because then other people will do the tooling for you, and that's always good. So I quite like OpenAPI specification. It supports the concept of spec first API design, the idea that we can write our specification first and then build the API. The rather neat thing about doing it that way round is that you can then use other tools like a mock server. So there are mock servers out there that will read your specification and create a pretend version of your API. So your client developers can integrate against it whilst you're still writing the actual API. That can be quite helpful if you've got, say, a team working on the mobile app and you're still writing the API because we're all behind schedule, or the deadline's been moved forward. You know how these things work. OpenAPI.tools is the website to find out everything you need to know about OpenAPI, all the tooling available for you. It's a really good list of what's available, and it's maintained by a guy called Phil, who has spoken here, and Matt Trask. They're both PHP people. That's a really good website. The tutorial information is the way you teach your developers how to do it correctly so that they can actually use your API properly. And the bit that's most important there is how to do the authentication, because that's the bit that mostly confuses people. But how you want your API to be used, what its philosophy is, tutorials on how to use it well, and the workflows you expect it to be used for, that all goes in your tutorial documentation. It's all long form, it's all prose. Use whatever works for you in terms of generating it. The one I'm currently working on is a WordPress site. That's where all our docs are going. They're just going straight into WordPress, and that's where we've got all our tutorials and stuff like that. Works really well. Other people are using static site generators. I don't mind. I just would like to see some good docs. About security. I'm not going to talk much about security because that's a topic in its own right, and we need someone like Katie to come down and teach us how to do it properly. Things I do want to consider, though, is your authentication. You're going to authenticate your API. You are not going to write a completely open API in this day and age. I've updated this slide because I no longer say that it's going to be under TLS, because surely nobody is not using SSL nowadays. If you're going to do your authentication, use OAuth 2. You're going to need to use a standard. Do not ever roll your own authentication system. You people are bright, I know this, but you are not bright enough to write your own authentication system. Clever people have done that. It's called OAuth 2. Just use it. It covers every use case that you will need. If you think you have got a unique use case, you haven't. It is covered. Just use the standard. The nice thing about using the standard is that all your client developers can use a client library to integrate against it, so they don't have to hand roll their own code to do the authentication, which means that one, they won't screw it up, and B, they will save time, so they will want to use your API. It's just easier. Rate limit your API. One of the easiest ways to bring down an API is just to hit it with too many requests and just wipe it out. If you've got lots of clients and they are worth different amounts to you, like you've got clients that are key to key to your business and clients that are maybe not so key, then maybe you should allocate your server resources appropriate to the money that those people are bringing into your company. We do that via rate limiting. It's not a formal standard on it, but nearly every rate limiting API uses these three header fields. X rate limit limit, X rate limit remaining, and X rate limit reset. Essentially, the idea is that you have so many requests you can do in a certain amount of time. So in this particular case, we have 5,000 requests that we can do. We've used up all 5,000 of them, and at that time, I will get my 5,000 back. So I can quite easily work out, as a client developer, that I'm using too much of the resources that I'm allocated. It will make your life easier if you bake this in early into your API. It's a bit like authentication. Adding this stuff on later is much harder than doing it whilst you're writing it in the first place. So if you can, write it earlier. Again, when it goes wrong, we're going to send the status code. 429 is the one that means that you've exceeded your rate limit. So see at 429, bad things are happening. Wait a while, go for a cup of tea, come back, you'll be able to use it again. So that's it. So those are my key things that I want you to think about when you're building APIs. I want you to think about your malleability. I want you to think about how easy it is for you to change your database schema and not affecting the payloads that you're sending down the wire. I want you to make your APIs correct. I want you to use status codes correctly. I want you to use verbs correctly. I want you to read the headers for content type and accept and actually get the HTTP side correct. It will make everyone who works with your API happier. I want you to do really, really good errors. Don't forget, we care about the errors because they're the ones that our client developers use. And our client developers will want to be able to read our documentation, so we will get it right. And finally, make sure you authenticate your API and don't screw up the security. If you don't know what you're doing in terms of security, hire someone or get some resources in that can teach you how to do your security right. Because leaking all the data is so embarrassing. If it's my data that I've put into your API that you've then leaked, that's just not a good look, is it? So let's try not to do that. And that's it. Thank you very much. Let's go to the pub.